Hi, I'm Neil Feit of the Philosophy Department at SUNY Fredonia. In this logic video, I'm going to be doing proofs with equivalence rules in statement logic. And I'm going to be doing a few challenging proofs. If you want a video on more basic proofs, you could check out my Logic8 video, Proofs in Statement Logic. I'm going to go down. This video is going to supplement 8.2 and 8.3 of the Power of Logic textbook if you're using that book. I'm going to do one from 8.3c. Exercise 8.3 involves 5 equivalence rules that are introduced in that section, but it also incorporates some of the rules that are used in the preceding section, 8.2. I'm going to go down to number 11. This is going to be a short proof, but somebody in my logic class recently wanted to see a proof with a certain rule, so I'm going to do one with that rule. Okay. I invite you actually to pause the video for a moment if you want to maybe try to figure this out. Okay, here the conclusion is not Z, which makes me think of using modus tollens with line 2. Okay, if I could get the negation of the then part, the consequent of line 2, then I could get not Z. The consequent itself is a negation. Okay, so I would want the double negation of what's in the square brackets there, and by double negation I could just add 2 tildes if I had what's in the square brackets. So basically, my strategy in this proof, if you want to put it on your wish list, is to basically get what's in the square brackets there in that part of premise 2. If you look at premise 1, that's an extraordinarily similar statement. Okay, in fact, it's a logically equivalent statement, and we have a rule, the rule of exportation, that allows us to move from one to the other. Okay, so if you look at that rule of exportation, and I encourage you to have the rules in front of you, okay, we could use the rule of exportation in the right to left direction. Remember, equivalence rules can be used in either direction to get what's in the square brackets there in premise 2. So I could take my u, then x, then w, and make it if u and x, then w. Okay, line 3 comes from line 1 by this exportation rule. Okay, and now I really do officially, strictly, correctly need to double negate that to get modus tollens with premise 2, because again the then part, the q part of line 2 is already a negation, so not q is going to be a double negation. Okay, before I put the 2 tildes there, officially and strictly there are outermost parentheses in line 3. I just omitted them for convenience a little bit. Okay, but they are there. And if I want to negate premise 3 or double negate it or any line like that, I've got to put them back because I'm negating, in this case double negating, the whole conditional and not just the u and x part. Okay, if you prefer square brackets instead of the regular parentheses, that's fine. There really is no difference. They're the same from the logical point of view. So that's a 3dn. Okay. Now, line 4 is the negation of the consequent of line 2, and I could get not z by the modus tollens that I was talking about. That's going to be 2, 4 modus tollens. Okay, and if I check this proof, hopefully it's going to say congratulations. Okay, the congratulations here tells us that it's not only correct so far as it goes, but it's also a complete proof, a correct proof of the conclusion. I'm not going to choose another from exercise 8.3c. I'm going to go over to 8.3d, do a couple of longer proofs in the remainder of this video. I'm going to scroll down to number 19 here. Okay, this is going to be a fairly challenging proof. This has 4 premises, so the next line is going to be number 5. I actually invite you to pause the video if you'd like for a few moments and just wrap your head around this argument and see what you think you might do to start this. Maybe even start thinking about a wish list. Okay, well, I'm going to maybe do an official wish list here. Okay, obviously I want to derive my conclusion, at which point I'll have a proof. Okay, Depending upon where you are in logic, you might have heard of conditional proof. In this exercise, we're not yet there, so really we're not really allowed to use that rule yet. And even if you were allowed to use it, it really wouldn't be helpful here because think about it. You would assume R for conditional proof here, but if you look at the premises of this argument, there is no R there at all. So assuming R is not going to do us much good. That might make you think of some tips. Chapter 8 of the Power of Logic book gives various tips, I think 12 tips for doing proofs. And tip 5 is this. If the conclusion has a statement letter that isn't in the premises, in this case it's R, use the rule of addition. Okay, that is actually going to be helpful here. It might be a little bit mysterious right now because addition involves disjunctions, and what we want to prove here is an if-then, a conditional. However, if you look down at tip number 10, you see that addition can lead to useful applications of material implication. So here's the idea. If R then U on my wish list is logically equivalent to not R or U, and we have a material implication rule that lets us go back and forth between them. So if I got U by itself, I could use addition to get not R or U, and I could use material implication to get up to R then U. So if I had U by itself, I would be 2 steps away from my conclusion. Okay? And now you might look at premise 4. Premise 4 can be turned into if K then U and if U then K. And if I had K then U, I could get U provided that I have K. Okay, so if I had K all by itself on a line, I could follow, that would come from premise 4. I could follow it on up, modus ponens, to my conclusion. So basically my target here is going to be to get K by itself. Okay, I'm actually going to erase this wish list and try to get going. And if you want, you could pause again and think about how you might actually get started on this proof. Okay. What I was just talking about was using the version of the material implication, excuse me, material equivalence rule that lets us break a biconditional down, to if the left then the right, and if the right then the left. Okay, that version of the rule is going to be more helpful to us here. So line 5 is comes from line 4 by material implication. I really don't need, I do need uppercase for my statement letters, but not for the rules. And I'm going to simplify. Line 5 is a conjunction. That dot is the main operator, so I can get K then U simplified out of there. That's going to be a 5 simp. Okay. Okay, so now if I had K by itself, I could get U with modus ponens line 6 and then follow those logical breadcrumbs back up my wish list to the conclusion. Okay, so now the trick is how to get K by itself. Okay, you might think of simplifying premise 1, which is legitimate. The dot there is the main operator, and oftentimes, I mean, arguably most of the time, simplifying a conjunction is a good way to go. And you can do the proof that way, but it's actually going to be longer and more challenging than the way that I'm about to do the proof. And in fact, I kind of encourage you to practice doing it that way. I'm actually going to not simplify premise 1. I'm going to use the distribution rule on premise 1, and I'm going to kind of talk through why I'm going to do that. Okay, basically, so I want to get K by itself. I see that not K is the antecedent in premise 2 and in premise 3. Okay, and basically what I'm going to do is kind of roughly use the contraposition rule. I'm going to take the contrapositive of premise 2 and premise 3 to make K by itself the consequent, the then part. Okay, so I'm going to take premise 2 and I'm going to use the contraposition rule in the left to right direction, which is the only way I can use it in premise 2. I'm going to make not K then E into not E then not K. Okay, so that's a 2 contraposition. And I don't like those 2 tildes in front of K, so I'm just going to get rid of them with double negation. In general, unless there's an obvious reason why you need a double negation, it's often helpful, often helpful just to get rid of them. Okay, so now line 8 says if not E then K. Okay, and again I'm going to want to get K. I'm going to do roughly the same thing on premise 3, except on premise 3 what I'm going to do first is use De Morgan's on the consequent. So not Z or not W becomes not Z and W. Okay, so that's actually De Morgan's. Again, I'm using an equivalence rule of De Morgan's here on line 3. And again, equivalence rules can be applied to sub-formulas, parts of lines, as well as whole lines. And I just applied that to the consequent of premise 3, carrying down the not K arrow. Okay. Now I could actually use contraposition in the right to left direction because I have a negation, a negated antecedent and a negated consequent. So I could just get Z and W then K. That's going to be 9 contraposition. Okay. Now notice I have not E then K, and I have Z or W then K. Okay. I'm actually thinking of the constructive dilemma rule. If I had the if part of line 8, not E, or the if part of line 10, Z and W, okay, I could use that with 8 and 10 to get K, the then part of line 8, or K, the then part of line 10. That's constructive dilemma. Now K or K is a special disjunction because it's logically equivalent by K to K. By the redundancy rule, we can move back and forth between them. So this is kind of what I'm going to be wanting to do the next few steps in this proof. Okay, but how to get this? Well, that's why I was talking about not simplifying line 1, but using the distribution rule. Okay, if you have something or something and that very same something or something else, that might make you think that distribution is potentially helpful. Okay, and that's what I'm going to do. I'm going to use line 1 and make it not E or Z and W. Okay, and that is from line 1 by distribution. Now I could actually have my 8, 10, 11 constructive dilemma that I was talking about to get K or K. And what did I say? 8, 10, 11, CD. Okay, remember, line 11 is an OR statement. Line 8 says that the left disjunct leads to K. Material implies K. Line 10 says that the right disjunct leads to K. Okay, so we get K or K. Well, by our redundancy rule, we could just change that into what it is equivalent to, K. So 13 is a 12 RE redundancy. Now I'm going to follow my sort of wish list back home. I could just get U here. That's using line 6 again with line 13, just modus ponens. Okay. If you look at the addition rule, you could, there's 2 versions of it, right and left version. If you just have a statement, you could add something onto the left of it. Anything you want. So I'm going to take that U and make it not R or U. Okay, that's addition from line 14, ADD. And 16, material implication is R then U, following back that wish list that I had on screen at the beginning of this proof. That comes from line 15, MI, material implication. Okay. If you simplified line 1 instead of using distribution, you can do this proof. It's more steps, I think. It involves some going back and forth between OR statements and then statements, if-then statements using material implication. And you might need to use double negation in there a little bit and using hypothetical syllogism. But I'm going to check this version of the proof. And we do have a proof here, so that's good. I'm going to try to squeeze one more into this video. Okay, I'm going to go down to 22. I'm not going to spend too much time on it. But what the heck, I'll do one more. Okay. Here we want to prove a conjunction. If you are studying logic and you've heard of the RAA rule, reductio ad absurdum, you might want to prove, the not T part of this conjunction by RAA, assume T, and, get a contradiction, and that might be a pretty good way to do that. But here we don't have that rule at our disposal yet. So I'm going to try to prove this directly. I'm going to try to prove not T, I'm going to try to prove S, and use conjunction to get them together. Okay? This is a little bit of a tricky proof. Here we have a conditional R then S, and basically, well, let me maybe hold off on that for a second. Basically, I'm going to want to do something to line 3, one of the material equivalence rules, and it's a pretty important decision to make which version of that rule you use. And generally, I want to prove S here. It's one of the things I want to prove. Okay, and I could break this down into not R then S and S then not R, and that would be good if I had like not R by itself to get S. But here I really don't have that by itself. Okay, so that makes me think that the other version of material equivalence is what I'm going to want to use. Okay, the other version of the bottom version of the ME rule. So I'm going to take not R if and only if S, and I'm going to use the bottom ME rule. I'm going to say, well, either they're both true, not R and S, or they're both false. So not R and not S. Okay. So again, this is a kind of a challenging proof, but I'm going to try to make it clear why this might be helpful. Okay. Now we have a disjunction in line 4, and if you use this version of the material equivalence rule, you should, in a lot of cases, be thinking, oh, how can I use disjunctive syllogism with this? I have an or statement after all. How could I use disjunctive syllogism? Okay, and notice again, S is something that you want to prove, and if you could get this half of line 4 all by itself, you could simplify out the S. So that's one way to get S here. Okay, so if I'm thinking disjunctive syllogism, I might want to get the denial of that. Okay, maybe what I should do first, make things a little bit simpler, is, in fact, I could maybe save a few seconds here. Just take this, copy it, and paste it here. Okay. Basically, I'm going to use double negation. Just get rid of those two tildes. So for dn, just makes it easier on the eyes a little bit. Okay. If I could get the negation of that, not R and not S, I could use that with disjunctive syllogism line 5. Well, what's that equivalent to? Let me think about De Morgan's rule. Not R and not S is equivalent to not R or not S. Okay, and this is kind of what I was thinking about before. Line 2 by material implication is equivalent to not R or S. Okay, and then if I just double negate this S, I could get this. You feel free to pause it, but that's going to be my strategy here. I'm going to take line 2, I'm going to use material implication and double negation and De Morgan's to kind of get the, are you with me? Get the denial of the right disjunct of premise 5, line 5. Okay, so let me take line 2, make that not R or S. Okay, that's a 2mi. What did I say I wanted to do? Not R or, just double negate that S, not S. Okay, 6dn. Oop. Use De Morgan's, make that not R and not S. That is the De Morgan's rule. If you're looking at De Morgan's, one of the De Morgan's laws, the top De Morgan's law in the right to left direction. Okay, so that's 7 dem for De Morgan's. Okay. Now notice what I have. My line 8 is the denial of the right disjunct of line 5. So I could use disjunctive syllogism to get the left side of line 5, not R and S. And S, okay. That's a 5, 8 ds. I do need a comma between the 5 and the 8, but I don't need anything afterwards. Okay, and S is part of what I want to prove, so now I'm going to simplify out S. Okay, that's going to be a 9 simp. Okay, what's the other part of what I want to prove? Well, not T. If I look up to line 1, I see that it's if T then R, so I'm going to want to get not R. Well, I have not R on line 9, so let me simplify that out too. Oops. Okay. So not R together with line 1 gives me not T. T then R, not T. That's a 1, 11 modus tollens. Got my moto running. Now I have half of what I want to prove in line 12, not T, and the other half of what I want to prove in line 10. So I could use conjunction. What's that? 10, 12? 10, 12 conj to derive my conclusion. Okay, I'm going to check this proof for the record. Let's see if I kind of named all the rules right and stuff like that. Okay, that is a correct proof. So we did do some challenging arguments here, including moderately long proofs. I hope this was helpful in improving your ability to understand doing proofs with equivalence rules. There's no substitute for doing it by yourself.